Everybody, welcome to my talk today, making commercial quality 3D games with open source software. Um, I'm really pleased to be here. Let me just move myself to the right corner. All right, done. Too easy. Let's get going. Um, Introduction. Who is this talk for? Well, I'm Luke Miller. I'm a game dev. I made a game called Liberation, which is what I'm demoing here as part of Melbourne International Games Week, Steam Festival. Thank you to Melbourne International Games Week, Steam Festival for having me, for hosting my game. It's just really exciting to be invited to be part of this. Well, I sort of elbowed my way in. Melbourne's got a really great game scene. We're very lucky because we've got a bit of government funding too, which really is like manna from heaven. Yeah, although Liberation, not a government-funded game, so I don't know what that means. But yeah, let's move on to the next thing. Who's this talk for? So I think this talk is really for kind of two groups of people. If you're like a small team or a solo dev, um, and you're kind of thinking about like how do I grow my business a little bit? How do I like what am I missing out on? Like people keep mentioning open source tools or Godot. Should I switch? Should I sort of learn about it? That this is for you a little bit to give you a bit of sort of a little bit of like a slightly advanced overview. The other people that this talk might be good for is if you're a business owner, like a game dev business owner, and you're thinking medium term. You're thinking about like, where do I want my business to be? What do I want the pipeline to be in a few years? Yeah, so that's kind of who this talk's for. Like, if you're a game player, you might not get much out of this, except that you might learn a little bit about like how games are made. But that's all right. Not everything can be for everyone. Let's move on to the next slide. I've got the slides here. Here we go. Yes, Liberation. We've got to talk about my game. It was made entirely with open source software. It's a retro space adventure. It was inspired by the original Elite from the 1980s. A lot of you are probably familiar with Elite Dangerous, but that's the fourth one in the series. So it's inspired by Elite from the 1980s, but also British science fiction, and like I call it like BBC videotape science fiction, like the Tom Baker Doctor Who, Blake Seven, Star Cops, Tripods. Because I was thinking one day all those things came out at around the same time from the same area. So Elite is an English game, classic or British game, I should say, and all that science fiction is also British from around the same time. And I reckon there was a cross-pollination effect that's never really been kind of explored, kind of tying those two universes together. And at the same time, I was kind of unhappy with where the Elite series went. Like they were too real, in my opinion. Like, I mean, I don't want to talk them down or anything because they are amazing achievements and like just amazing achievements. But I was always like, that's not what I would have done with Elite. The hubris is real on this one. So Liberation is kind of like my alt historical. So imagine if like Rome had never lost its empire. Imagine if computers had frozen and Elite had kind of gone down a Hitchhiker's Guide to the Galaxy path. That's Liberation. What else is there to say about it? This is the first game where I did all the art. That's why I think this is a good talk, because, as I said, this was entirely an open source software stack used in this game. Yes, which I guess brings me to the next slide. What is a stack? So a software stack is the entire set of software used to deliver the end product, sometimes called an ecosystem. So, we talk about like the Apple ecosystem, but that's actually like the Apple software stack. And if you ask most game developers when they start out, oh, what software did you use to make your game? They'll probably tell you just the engine. They'll go, oh, I used Unity or I used Unreal. But actually, that's just one tool in the entire stack, from like the operating system all the way up to, what store you're using. Like Steam is part of your stack in a way. So yeah, so when we talk about game development, the stack might be is this whole suite of software used, including for planning. So if you use Miro or Jira or Trello, or like a Word document, like Word or whatever. That's part of your stack, really, because game development is only a little bit about the coding. It's about the whole pipeline, really. The tools used to create the art and sound, so Photoshop, if you use that to do the drawing, that's part of your stack. The OS underneath the tools is also part of your stack. People don't really consider it, but obviously it's big. It's a massive part of it, like millions and millions of lines of code, tens of millions of lines of code. The game engine obviously is probably the most visible bit of your stack. Godot, Unreal, Unity, Bitsy, RenPy, your own that you've written, you foolish mortals. The code repository code that you use, so Git is kind of the industry standard at the moment. That's part of your stack. The build system. So I mean, most engines have that built in these days, but your build system is part of your stack, and of course, obviously, how you deploy it and the store is part of your stack too. You know, so you may consider itch as part of your stack or Steam as part of your stack. It's about those layers. I'm sure that's like the traditional meaning of the word stack if we went back to medieval ages, but it's lost all meaning to me. Now it just means software stack. Why am I talking about the stack so much when you came here to go like, oh, I thought this was just going to be about why Godot is so awesome? Because the stack really matters, especially if you're making a game, just pick an engine and go for it, whatever. But as I said, this talk is aimed a little bit more about people who want to kind of build out their pipeline. They want to make a machine that makes games. They want a business that makes games. It's time to consider your stack. Because a good stack just makes the process so much easier. It means it streamlines the process. Like if your stack is a mess, you just always like a classic mistake with a stack is asset management. So just say someone is using a program to use art, but it's not in the right format for the game engine, and so you've got to have like another 5 or 6 steps to get the art into your engine. That's a bad stack. So a good stack will just let the artist just put the art in the engine so they can see what's happening real time, all that sort of stuff. A good stack means you can find talent to plug into your stack. So if you've written your own engine, this is a classic one, writing your own engine, who do you hire to take that over for you? You know what I mean? You can't, because they don't have the skill set. But if you're using really popular software that's industry standard in your stack, it's a lot easier to find talent to work with. The initial cost of your stack, if you pick expensive software, so like big software, and you're only making a little project, it can be very expensive, where there might be like lower cost or no cost alternatives. The ongoing costs, like if you pick subscription software or you use a cloud service, that has a monthly cost. That can get expensive too. Long-term support, if you pick software and if you have software in your stack that just drops out, that can unbalance your whole project, and that can destroy your stack. Like, what if one day the engine vanished, like literally stopped running, and there was no way to get it running ever again? Your project's dead. Code rot. So you may not be familiar with that, but code that doesn't change can actually rot over the years. So if you think of all those people that wrote games in Flash, or like Turbo Pascal or Visual Basic, those games don't really run anymore without a lot of work, even though the code didn't change. But just over the years, the computers moved on, the ecosystem moved on, and so that code rotted. So if with a good stack, your code will stay fresher longer. Feature set, obviously you want a stack that gives you the features you need to make your games. Like, so many people have an existing stack, like maybe they make 2D games and they decide to make a 3D game, but the stack's not designed for 3D games. It doesn't really do the asset management stuff really well. It doesn't scale up to 5 people. Like, just say you're running a pipeline for one person. Reliability, like a good stack will sort of induce quality as you go through. Like, if you've got an operating system that's rock solid, if you've got art programs that are rock solid, if you've got audio programs that are rock solid, you're going to get better results than code that's sort of dropping in and out. And the flip side of that is you'll get quality output if you've got a good stack. So if you've got a good sound program, the output is going to be mixed better for your games and stuff. So yeah, that's why the stack matters. Most people don't really consider their stack initially, but they should. And so I guess part of what I want to get out of this talk is like, how do you evaluate is if a piece of software is good for your stack. I believe personally you should always pick the right tool for the right job. So I would never rule out closed source applications because there are a lot of great closed source applications and a lot of closed source applications that do stuff that open source doesn't do. But my rule of thumb is that if it's open source, that's a massive bonus. So like I know if it's an open source piece of software, it'll probably slot into my pipeline with minimal hassle, and I can probably trust it long term. And trust it on a variety of levels. Trust it for reliability and trust it in licensing and like long-term support and stuff. So that's not just a Luke thing. That's kind of where software engineering has actually kind of landed culturally around the planet. Software stacks have kind of divided into roughly two camps: closed source and open source. And then a really awkward open source but closed cloud sort of component in the middle. So like Gmail or AWS, they are technically open source, but because they're running on someone else's computer, you can't see what they're doing, and nobody quite knows what that means. But you don't really need to worry about that for your stack. Because you're just you're one person or a small group of people. You can't carry the whole world on your shoulders. God, you just got to take that burden and put it down, man. Yeah, so open source versus closed source. I don't quite know. I think how do we end up there? I don't know. There's a sort of kind of Highlander aspect to it. Like only one can be right. I'm not going to get into it though. But I don't know. It is a little bit like barracking for a sports team, and I'm in the open source camp. Let me just check my notes. All right, so looking at those two camps, open source versus closed source, very important in engineering, but I guess as you get higher up the stack, like if you're an end user, you don't really care whether it's open source or closed source. If you're an artist, you probably don't really care if it's closed source or open source. If you're like a business person, you probably don't really care, but it kind of gets more important as you get down. And also ecosystems tend to kind of there's sort of like what do you call it? Things clump together a bit in ecosystems. So if you start using open source software, it's sort of easier to use other open source software. If you're using closed source software, it's easier to use closed source software. So you kind of have to kind of commit in a way eventually. Historically, the perception has been that open source software has been good for low-level engineering, like servers and stuff like that, and closed source has been good for casual users and artists, like that's sort of the tractor versus the sports car. Like if you want to plow a field, you need a tractor. You can't use the sports car. But if you want to attract that cute guy to come over and chat to you, maybe a sports car. Actually, they probably like tractors too. But there's a metaphor in there. Figure it out yourself. I kind of prefer to think of it as a bit more like tortoise versus the hare. Where yes, maybe open source can start off a bit slower, but over a long time, it just continuously improves and gets better and better and better. And closed source just can't compete with that. I have a personal example in my own life. I started a little Python library about 6 years ago, and every month I get like 1 or 2 lines of code. Other people just send me 1 or 2 lines of code to add to it or to change it. And over 6 years, that library has just gotten faster and better and more reliable and more comprehensive and used by more and more people. And it's just really amazing to kind of see that community effort just slowly but surely, brick by brick, build something wonderful. So yes, I guess with open source, it's not just like a commercial decision. There's also is it your vibe? And I think for the right people, open source is a really great vibe. If you like triple R, like community radio, open source is for you. My stack. So back to Liberation, back to making a game entirely using open source software. Here it is. So if you're looking at it, if you're reading this slide, if you're going to roll your eyes at anything, I reckon it's the art tools line, where I mention GIMP and Inkscape instead of Photoshop and Illustrator. That's fair. That's absolutely fair. But when you look at this stack, you're probably already using some of these tools, like Firefox and Chrome. I've listed Firefox here, but Chrome is also open source. Firefox and Chrome are open source products. They're best in class. OBS, I mean, everybody uses OBS at the moment. That's a classic open source project. Sound, Audacity, GIMP, and Inkscape. I mean, they'll never be as good. Like, let's face it, the industry standard ones like Photoshop and Illustrator. But I put it to you, unless you're like a world-class artist, are you really using those extra features that Photoshop give you that, GIMP and Inkscape can't? Get over yourself. Shotcut is a video editor that nobody's heard of, and it's not a very good one, but all I need is to edit and do crossfades and stuff like that, and it's perfect for that. And of course, Blender. Blender's really amazing. I mean, it's horrible, but also it's amazing. To be fair, it did start as closed source like 20 years ago or 30 years ago, but it's been open source for so long. And open source is what supercharged it. Engine, I used Godot. I used to write my own. I would never say to someone who's using Unreal, a team using Unreal or Unity, I would never say to them to switch over to Godot because it's such a personal choice, or it's so dependent on the skill set or on the mentality or whatever. But if you've written your own engines in the past, Godot is excellent for you, and it's open source. And once again, it is getting better and better. It's not quite at a corporate level. Like, I definitely think small teams can use Godot, but I wouldn't recommend it for like Blizzard or whatever. If you're watching Blizzard, don't switch over to Godot. And perhaps like where I'm going to lose a lot of you is I use Linux. I've used it for like 25 years and I've been very happy with it. What am I saying? So, I mean, as a quick aside on, like you're watching this because maybe you're curious about what open source is, and a big part of that is Linux. And don't let that lose you. Like, I'm not saying switch over to Linux tomorrow, but just kind of be aware when you think of the tools you're using. The internet, like you're probably using Jira or Trello or Gmail or whatever. Those things run in Firefox just fine on Linux. So you've got Firefox, you've got Godot, you've got Blender, you've got Git, you've got Steamworks. Those are all actually written on Linux for Linux users. They're like native Linux apps. And so you actually get, in my experience, a better experience using them on Linux. But I understand that that's like sort of a bit out there. But I would kind of encourage you that when you're picking a piece of software to go in your stack, check if it's like a Linux friendly version. And open source is really good for that because those skills are transferable. Because maybe one day you'll be in a shop that is running Linux. Yes. But I don't want to... I mean, no, I'm going to go back to the Linux thing just quickly because I really love it. So, most of the peripherals use out of the box. Like, I just plugged in my Xbox One controller and it just works. No messing about with drivers. Tablets work. Most USB peripherals work, like the cameras and all that sort of stuff. But what's really missing is like the Adobe stuff, Photoshop and Illustrator. That's the way it is. Maybe I think Linux people, we've kind of made our peace with it, and we're like, actually, we don't want them here. Oh, well, there we go. I was going to say, I was trying to be honest about the drawbacks, but I actually had a whole slide of drawbacks for you. With an open source stack software, sometimes I would say the main drawback is there's a missing segment for really large corporate use. So a massive part of working for a big company is if something goes wrong, you can call a support line and go, look, we're paying you 100 grand a year. This is not working. Fix it. And they'll get on it. Open source doesn't always have that. It does for a lot of layers in the stack. Like Linux is well supported. Firefox is well supported, all that sort of stuff. And Godot is kind of half there. But with a lot of the little layers, there's no one you can really call and say at like 2 o'clock in the morning, say, stop running, go fix it. So once again, this is why an open source stack at the moment is more suited for solo devs or small teams. Obviously, some of the layers in your stack are missing industry standard. Like, a lot of the stack is industry standard. Like, you think Git is industry standard. GLTF is industry standard, that sort of stuff. That's all. Linux has got all of that. But it doesn't have Photoshop. It doesn't have some of the audio stuff. And maybe this is a drawback for you, but I consider this almost a positive. Is that if you do use a lot of open source software, there's an expectation that you should be part of that community. So if you're using a piece of open source software and you make a change to it, consider contributing that back to the original project. Because that's just sort of being a good neighbor. But I've cheated by putting the drawbacks first and then the benefits next. Because there are a lot of more benefits in my mind. There's low ongoing costs. When I think of Liberation, 6 month development cycle, there were no subscription costs for that software stack. There's license certainty. Even as I record this, there's a bit of a kerfuffle in the Unity land where the company has announced a per install fee. Excuse me for a moment. Which everybody is saying won't stand. Probably not, whatever. But with open source software, just by the nature of the license, it's extremely hard or impossible for an open source project to be retroactively changed like that. Or even changed at all. Like the license is set. Because so many people contribute, it's very hard to kind of change the license after the project started. Because if you do, people can just take the code and keep working on a different fork. Benefits, integration. Yes, well, as I said, that stack is very, very clean. I have scripts on my computer. I can push a build of Liberation up to Steam in just a minute or two. I could do it on a code commit if I wanted. So it's very clean, very streamlined, very integrated pipelines if you get it working right. Industry standard, as I said, a lot of the layers in the stack are industry standard. In the closed source stack, some layers are industry standard too. So it's kind of like, I reckon that's a wash, to be honest. Transferable skills. If you learn how to use Git, whatever game shop you go to, Git's probably there. And if it's not Git, then it'll be some other open source code repository. Stuff like that. So it's pretty good. And it's future-proof. As I said, some of the games I wrote, they still run, no problems. Just because the source is available, and it still compiles, which is pretty useful. 5, 10, 20 years later, so many Flash games are very hard to run nowadays, unfortunately. And a big part of that is because it was all closed source at the time. And we only had the binaries from a lot of those projects. And of course, the biggest benefit, I think, of open source is that it's accessible to everyone regardless of income. There are kids around the world who are actually programming games on their phones. So if you ever wonder about that you've got a hard, just think of that some kid who's typing it up on their phone. And I just think how amazing that the transfer of, I guess, knowledge wealth using open source software has been. When you think of all the servers, Wikipedia is running on open source software, think of all the knowledge that's been shared through something like Wikipedia. And it's all happened just because people contributing a line or two here or there. It's a really beautiful thing and worth supporting. And just a good vibe. Well, we're almost at the end. So, that was my little pitch to using an open source stack. I probably should have done a little bit more about how I did it. What are you really going to learn in 25 minutes, coding-wise? I do have my little tips for using Godot. Use signals. That's an absolute must. But use them in a singleton. Don't do the cascading signal thing. That's terrible. You'll just get spaghetti code. So just have a singleton file where here are my 100 signals for my game. And then you can just use them in all your nodes. Use groups. Add to group is your friend. Pretty good feature in Godot that not many people use. Don't use repo Godot or point release or beta release Godot. Stick to the long-term service or the main releases because it's a bit of a shifting code base Godot. Headless Godot is really great for continuous integration, continuous development. If you're a solo dev or a small team and you're how can I make my how can I make that machine that makes games? You've got to get on top of your testing. You've got to automate your tests. And Godot is like halfway there, I reckon. They don't do much. They're testing. The devs on that are a little bit loose with their testing, but that doesn't mean you have to be. And headless Godot is a really great way to write your tests, and then when you do a code commit or a code push, you can run those tests in the background, and that way you can sort of get quality code. Don't neglect it. Godot 4 lets you import blend files directly. So what I did with Liberation is I would edit I'd create art in Blender, and I would save the file in the Godot directory. And then when I switch to Godot, it just automatically imports and it's there. So you make a change in Blender, it's there in Godot. I'm just like, that was delicious. That was a really great improvement to my pipeline. Yeah, so I mean, a little side spiel there about one particular layer, which is Godot. I actually think it's ready to use for professional games, which is one of the reasons I did it. Yes, so coming back from that little divergence, back to I guess kind of my main concluding message that I want from this open source stack is that a model or like what do you call it? A pattern that I would recommend to small shops is something called the paved road, where you have your open source stack. You have your continuous integration, continuous development model running on Linux or whatever. You're using Git, you're using Godot, all that sort of stuff. But then that's your paved road, and you say this is what we spend our time integrating. This is the official stack that we use. But if you as an artist need to use Photoshop, or if you as a programmer need to use, I don't know, Turbo Pascal or something, we're not going to lock you out of that. You can use that stuff, but it just is a little bit more tougher to integrate. And that's called the paved road. So if someone on your team doesn't want to use the paved road, or they want to go off onto the dirt track, it's allowed, but just keep in mind that it's like you want to make that paved road as smooth as possible for the people working on the team. Like, use the same shared documents, all that sort of stuff. Yeah, conclusion. Is that spelled right? I think so. So yeah, not only is it possible to use open source software to make commercial quality games, but for the right teams, it's the better option, in my opinion. Yeah, everything I want to say is kind of in that slide. Is there anything left to add before I let you go? Not only is it possible to use an open source. Yeah, I made Liberation with a completely open source stack for the first time. I've switched over to a whole open source stack. And I was very happy with the results. Very, very happy with the results. So I think it's there. I think it's there for small teams and solo devs. Not quite there for corporate users, but just every day it gets better in every way. So yeah, now's a good time to, well, if you're starting out, definitely go with Godot or whatever. But if you're like mid-career, I don't know, maybe there's no helping you. All right, thank you for joining me. Thanks once again to Melbourne International Games Week, Steam Festival folk for having me. And I'll see you all some other point. Bye.